بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على أشرف الأنبياء والمرسلين، نبينا محمد وعلى آله وصحبه أجمعين. أصحاب السعادة، ضيوفنا الكرام، أهلا بكم في رحاب الهيئة السعودية للمواصفات والمقاييس والجودة ضمن فعاليات ورشة عمل السيارات الكهربائية والسيارات الهجين، والذي تنظمها الهيئة بالتعاون مع شركائها، تأكيداً على المضي قدماً في مواكبة التطور التكنولوجي وتفعيل برامج وتقنيات الحفاظ على البيئة ورفع معدلات الكفاءة الطاقة وترشيد الاستهلاك. كما نشكر لكم حرصكم على الحضور ومشاركتنا في هذا اليوم، والشكر موصول لأصحاب السعادة وممثلي الشركات العالمية. الحفل الكريم. الآن كلمة محافظ الهيئة السعودية للمواصفات والمقاييس والجودة الدكتور سعد بن عثمان القصبي، استهلالا لهذه الورشة يلقيها نيابة عنه سعادة المهندس عبد الله بن عوض القحطاني، نائب المحافظ للمواصفات والمختبرات، فليتفضل مشكورا.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه ومن تبعهم بإحسان إلى يوم الدين. أصحاب السعادة، السلام عليكم ورحمة الله تعالى وبركاته. بداية أود أن أعبر لكم عن جزيل الشكر وأعرب لكم عن امتنان الكبير نظير حرصكم على المشاركة والحضور في هذه الفعالية التي نعتبرها نحن في الهيئة السعودية للمواصفات والمقاييس والجودة مناسبة في غاية الأهمية، كونها تناقش موضوع من مستجدات العصر الحديث والذي يواكب التطور التقني والتكنولوجي، وتتناول واحدة من أهم التحديات العالمية، وهي الاستدامة بيئياً واقتصادياً، وقضية التلوث البيئي الذي تستحوذ صناعة السيارات على نصيب كبير من مسبباته، نظير الانبعاثات الكربونية الصادرة من عوادم السيارات في الطرقات في كل لحظة. وبهذه المناسبة أحب أن أنوه بجهود الشركات العالمية المصنعة للسيارات، وأشكر ممثلي هذه الشركات على المشاركة بأوراق عمل اليوم والحضور لتبادل الآراء والخبرات من أجل الوصول إلى رؤى واضحة ومحددة، وتكون بداية لوضع ما يشبه خارطة طريق لتحرك المملكة نحو هذه الصناعة الواعدة، وهي صناعة السيارات الكهربائية والهجين. وأود أن أنبه بالتجربة الريادية السابقة للمملكة العربية السعودية في التعاون مع الشركات العالمية في مجال السيارات، والمتمثلة في التوقيع مع أكثر من 86 شركة من الجهات المشاركة في البرنامج السعودي لكفاءة الطاقة لتطبيق المعيار السعودي لاقتصاد الوقود. الإخوة الحضور، لا شك أن قضية كفاءة الاستخدام للوقود والتلوث البيئي والتوجه العالمي نحو الاعتماد على اقتصاديات صديقة للبيئة هو أمر واضح وضروري، ولا مجال أمامنا في المملكة سوى المشاركة وبقوة لتفعيل وتعزيز هذه الجهود. وهناك مسؤولية كبيرة ملقاة على عاتق المختصين والمسؤولين، كل في مجاله لتنفيذ تلك التوجهات تماشياً مع الرؤية الطموحة للمملكة 2030 وبرامج ومبادرات برنامج التحول الوطني 2020. ولعل المؤشرات الأولية على نجاح تجارب بعض الدول في استخدام السيارات الكهربائية والهجينة يؤكد أن بالإمكان سوية تقديم منتجات أقل استهلاكاً للوقود وأكثر كفاءة، وليس لها تأثيرات ضارة كبيرة على البيئة. إلا أن الظروف المناخية للمملكة العربية السعودية ودول الخليج بشكل عام كانت أحد الأسباب التي أدت إلى التأخير في الدخول في هذا المجال قبل الوصول إلى مؤشرات حول إمكانية مناسبة هذا النوع من السيارات للظروف المناخية لدينا. وتجارب بعض الدول الخليجية والعربية في هذا المجال مثل دولة الإمارات ومملكة الأردن هي دوافع لدراسة هذا الموضوع بشكل أعمق، وبحث سبل دعم هذه التقنيات وتعزيز تواجدها وتوفير البنية الفنية والتشريعية لها بالتعاون مع كافة الجهات ذات العلاقة سواء داخل المملكة أو خارجها. الحضور الكرام، تعمل الهيئة السعودية للمواصفات والمقاييس والجودة بالتعاون مع هيئة التقييس الخليجية بشكل دائم على مواكبة أحدث وأهم التقنيات في مجال صناعة السيارات، حيث أصدرت الهيئة 102 لائحة فنية و500 مواصفة قياسية سعودية خاصة بالمركبات والإطارات. وقامت الهيئة بتحديث اللائحة الفنية السعودية ساسو جي اس او 42/2015 السيارات المتطلبات العامة، وتم فيها إلزام جميع مصنعي السيارات بعدد من المتطلبات الخاصة بالسلامة، ومن أبرزها الوسائد الهوائية للسائق والراكب الأمامي، وكذلك الإلزام بوجود نظام مانع لانغلاق المكابح ABS، ونظام الثبات الإلكتروني ESC، ونظام التوقف الذكي للمكابح POS. وفي مجال السيارات الهجين تضمنت اللائحة العديد من المتطلبات الخاصة بها، وجاري العمل على بقية اللوائح لتتضمن هذه النوعية. كذلك تقوم هيئة التقييس الخليجية بإصدار شهادة المطابقة الخليجية للسيارات الهجين حتى يتم السماح لهذه النوعية من السيارات بالدخول لأسواق الخليج. كما أعدت اللجنة الفنية الخليجية للمركبات والإطارات مسودة مشروع لائحة فنية للسيارات الكهربائية يتضمن أهم المتطلبات الفنية، وتم توزيعه على الشركات الصانعة لإبداء المرئيات عليه، ويتوقع الانتهاء منه قبل نهاية العام الحالي. في الختام أكرر شكري وتقديري لجميع من حرص على الحضور والمشاركة، والشكر موصول للإخوة المتحدثين ممثلي الشركات العالمية المتخصصة في صناعة السيارات. والله أسأل أن يوفقنا للخروج من هذه الورشة بتوصيات تدعم وتعزز هذه الصناعة الواعدة، بما يعود بالنفع على الاقتصاد الوطني السعودي وتعزيز المكانة التنافسية لمملكتنا الحبيبة. والسلام عليكم ورحمة الله وبركاته.
الإخوة الكرام، نبدأ الآن أول محاضراتنا لهذا اليوم مع الأستاذ أندرو ريدزديل من شركة مرسيدس، هو مدير التدريب لخدمة ما بعد البيع في دايلمر الشرق الأوسط ودول الشرق، فليتفضل مشكور.
Good morning to everybody. We start with a couple of statements from gentlemen at the start of the automobile revolution. And these statements were generated from traditionalist conventional thinking at the time. And I think you can agree, if these traditional statements had have been more successful, we'd be living in a much different world today. In order to persuade people to take a less traditional method, we would need three basic implementations. Firstly, we would need to have vehicles which are practical and also suitable for daily use. This technology needs to be more affordable, and there should be infrastructure already for refueling this new technology much more conveniently for the customers, for the drivers. Typical customers who would consider to pioneer this new technology. Yes. Okay. Yeah, typical customers who would be persuadable to pioneer this technology would be kind of customers who are interested in innovative technology. They would be looking to pioneer the new vehicles. They would be interested to have environmental friendly fuel. They would also be interested to have reduced costs in fuel consumption, reduced costs in vehicle ownership, in maintenance of the vehicles. They also would be looking for convenience, to be able to refuel the vehicle at home rather than having to go to traditional fuel stations. And they would also want that the vehicle is providing them with driving pleasure, with power, with smoothness, and with reduced noise levels, for example. The technology is being driven. It's being driven by ever-increasing emission standards globally. The current situation cannot be sustained. So new technologies must take place to replace the current situation. To assist this, the battery development has been improved. Battery density has improved, which gives a bigger range to these kind of vehicles so that they can compete with the current vehicle technology. Also, this technology should be available in a wider range of vehicles. It should be able to appeal to a customer who wants to drive different types of cars, not only sedans, estate cars, but also SUVs, commercial vehicles, public transport vehicles. So in the coming years, we can expect a bigger increase of electronic vehicles, electric drive vehicles in the community. One manufacturer has already committed to investing 10 billion euros in the coming years in the development and further development of electric drive vehicles. Some governments are offering incentives towards the move. Could be with reduced vehicle taxation. Additionally, other incentives are clearer lanes, like bus lanes. And also by offering incentives like free parking, and even in some countries, public charging of the vehicle free of charge. Some national governments are already making some very bold statements about the future. And we can already see that between 8 and 13 years' time, there will be significant moves to embrace the new technology compared to the current technology that is available. Which technologies are, let's say, currently an option for the customers? The electric vehicles come in these formats. The mild hybrid vehicle. The mild hybrid vehicle has a conventional combustion engine drive with a compact electric motor and high voltage battery. This technology supports the motor, and therefore under acceleration and start off, the fuel consumption is reduced. So there's a considerable fuel saving. We can also say that the battery, which is supporting the engine, is recuperating, it's recharging the energy kinetically during overrun conditions, and also during recuperative braking. So it is ready for the next acceleration or the next start off to support the motor. The next type of vehicle is what we call a plug-in hybrid. This is a full hybrid vehicle. The battery on this vehicle is much bigger. This allows the vehicle additionally to drive with full electric drive rather than being supportive of the combustion engine. Not only is the battery recharged during driving in the kinetic and in the recuperation phase, but the battery can also be recharged statically when the vehicle is parked, either at home or in the environment, in public environment during shopping or business trips, for example. It offers very good or very low fuel consumption possibilities, and also has introduced new technologies like the haptic accelerator pedal. The third type of vehicle is a vehicle without a conventional internal combustion engine. It's a purely electric vehicle with an electric battery, a larger electric battery. The propulsion is purely by electric motor. This one has the advantage of pretty much the maximum power and torque from the initial start off. It has extremely low emissions, no exhaust emissions, and no audible, noise emissions. Yeah. And has a wide range of charging options similar to the plug-in hybrid. Let's have a look at the suitability of the different propulsion types. You can see here that with conventional internal combustion engines, as we all know, these are the most efficient, most fuel efficient and most emissions efficient when they are operating in the highway. At medium to high speeds, at constant throttle, they are the most fuel efficient. Their fuel efficiency drops off when we enter into the urban and into the city situation. In start and stop traffic conditions, the engines consume more gasoline and produce more pollutants, more emissions. If we have a look at the hybrid vehicles, the mild hybrid and the full hybrid, these, the technology is most advantageous in the starting and stop cycle. So these vehicles are more suited to urban and city driving situations. Although the technology is combined together with the internal combustion engine, the efficiency of the technology has little advantage when we are in high-speed, constant driving situations like on the highway. We have electric drive with range extender. Also is at home in the city, in start-stop, in traffic flow situations. This technology is offering the best environmental protection and also the most fuel efficient. However, it also has on board an a combustion engine in order to charge the battery separately of a charging point, which can give it a slightly extended range. On the electric drive vehicles, these are really at home in the city. They are not only more efficient at recuperating the energy in start-stop traffic situations, but they also offer the additional advantage of no emissions, so a much cleaner environment within the city. And as the batteries are year on year getting more and more efficient with their energy density, the range of these vehicles, the arrow to the left, will be extended due to developments in technology and they'll be more suitable for longer distance. The mild hybrid, a little bit more detail in that. This allows us to combine the high voltage advantages with the traditional internal combustion engine. The battery type is quite compact. The electric motor is built into the drivetrain, and this allows then for electrical support of the combustion engine in critical situations, like starting off. It allows us also to use a different kind of internal combustion engine, one using the Atkinson principle, which is much more fuel efficient in general, with the disadvantage that the acceleration is quite poor. But when supported by an electric motor, this disadvantage is completely eliminated, so the customer still recognizes the convenience of driving. The plug-in hybrid, which is the full hybrid, has a bigger battery technology. This allows the vehicle to drive purely with electrical means, not only supporting the gasoline engine or diesel engine, but actually driving completely independent of the internal combustion engine. This plug-in hybrid has also it's been modular designed, so it can be installed in different vehicle types, in sedans, in estates, in SUVs, also in bigger commercial vehicles and public vehicles. We see, for example, together with the low fuel consumption, the haptic accelerator, which is an electric device within the accelerator pedal, which is stimulating the driver. If the driver is over-accelerating with more power than is necessary, the accelerator pedal can give a small vibration to stimulate the driver to reduce the accelerator to a more efficient, more battery efficient and fuel efficient situation. On the battery electric vehicle, we have the advantage of no internal combustion engine and therefore zero emissions from vehicle exhaust, as well as very, very low noise emissions. These vehicles have a much wider range of electrical propulsion due to the bigger size of the battery. And other advantage is that because it's an electric motor, the maximum acceleration and torque is guaranteed more or less from an initial start off right through acceleration. These are very strong and powerful cars to drive from a standing start. The range extender is the same as the battery electric vehicle, with the addition that there is a small internal combustion engine also included. The disadvantage as far as the vehicle is concerned is that there must be some extra space for this conventional engine technology and also space for a small fuel tank. But the advantage of this range extender is that the conventional engine will drive a generator to further charge the battery, which extends the electrical driven range. But in the urban and city environment, this has no appreciable advantage compared to a full battery electric vehicle. If we look at the new technologies, at the heart of the new technologies is the high voltage battery. It's a central source of energy for the three main types mentioned previously. Significant changes and improvements in the battery technology in recent years means that these vehicles have a much longer and wider range than before. Yeah. At present, lithium ion is the preferred technology because this offers, for the weight and for the size, the highest energy density and therefore the more flexible of the electrical power sources. The electric motor is designed to power the vehicle, to drive the vehicle. It also has two secondary functions. The electric motor can be used as a starter motor to start the engine when we talk about the mild hybrid and full hybrid with integrated internal combustion engines. And the final point is that it is also used as an alternator. When the vehicle is in deacceleration or under braking mode, the motor can redirect the energy from the rear wheels back through the power electronics to the battery, to recharge the battery so we can extend the driving range. The power electronics is the interface between the battery and the electric motor. Electrical energy, as you know, is stored in direct current format, but this is no good for driving an AC motor. So the power electronics is converting the direct current of the battery to the AC current to drive the motor. So under propulsion, battery is for DC to AC. When the vehicle is deaccelerating and in recuperation mode, the AC motor is producing AC voltage, which is then converted into storable DC voltage to be put back into the battery. This kind of operation also generates a lot of heat, as you can imagine. And so the main components, the power electronics and the hybrid battery will need separate cooling systems. The charger, which is fitted onto the all-electric vehicles and into the plug-in hybrid vehicles, also takes power supply from a domestic or public source, usually AC, and is then converting that AC voltage into DC voltage for storage in the battery while the vehicle is parked. This kind of technology can also be designed modular so that it can be used with different vehicle types. In conjunction with a charging socket, the charging socket can be adapted to suit the vehicle and also to the infrastructure of the country where the vehicle is running. And this charging socket can be designed in various different formats to suit different kind of charging requirements. If we look at the batteries which we have today are giving quite a high range compared with the batteries of yesterday, but still it is the technology is growing rapidly, and in the next 3 years, by 2020, it's envisaged that the current situation of today will be improved by 30% by 2020. After 2020, it's envisaged that there will be a switch away from the lithium-ion technology, and there will be different technologies available for battery construction. And these are very promising materials which promise, at least the outlook is, that we will be getting 100% more range from the battery than in 2020. So a lot of research and development is going into battery construction and development. And we can see that since 1993, in average, year on year, the battery energy density and construction design has been improved in average by 7% year on year. So this is a very a steady growth, and this is, as we can see, it's expected to accelerate with upcoming new technologies in the near future. Different battery types operate in different temperature ranges. Our conventional lead-acid batteries and lead gel batteries operate up to temperatures typically of plus 45 degrees. We can see that lithium ion is quite comfortable operating up to between 50 or 55 degrees centigrade. And therefore, we do need on the vehicles a form of cooling system in order to maintain the optimum temperature, running temperature of the battery technology. Currently, today, there are 4 charging modes available to a customer with a hybrid or battery electric vehicle. I think rather than to read this one, I can show you a little bit more pictorially. We can see here that the current charging situation is taking an AC supply, whether it's domestic or whether it's a public supply, and connecting to the vehicle and via an AC-DC charger on board the vehicle is able to charge the battery. We can do this in various means. The mode number 1 is with a conventional 3-pin or 2-pin household plug, like you would use with a vacuum cleaner or some other television or a domestic appliance. And of course, the current which can be safely operated through such a plug is around 13 amps. Yeah. So charging cable to the vehicle can be connected on the other side with a simple domestic 13 amp plug. Also available, mode 2, is a slightly different plug type, more seen in industrial applications, but also in some domestic houses as well. And this plug is able to handle much higher currents. So we can charge with, let's say, up to 16 amps of current with this kind of plug. And mode 1 and mode 2, you will see that the charging cable has an electronics box in between the vehicle and the house. So the protection and regulation of the charging is maintained inside the cable. A third domestic option is with what we call a wall box. And the wall box interfaces to the house electric, and inside there are transformers which can boost the AC charging, let's say from 11 watts up to 22 watts. Currently, we have also the public situation. Public charging stations, which require a different kind of plug connector. These can handle much higher wattage. That's the current situation that we have today. Coming on the horizon, there are some additional options. There's a third AC option coming, which is inductive charging. The vehicle can be placed or driven over a mat, and then this mat is connected to the house or factory electrics, and by inductive means, without need for any cable connection between the vehicle and the facility, the battery can be inductively charged. This is possible. A second type of wall box is available for the domestic house supply, whereby inside the box the AC is converted directly to DC. This then, the DC electric is directly charging to the battery and not requiring to go through an AC-DC converter. And also in the public domain, we can see that there's also a stronger DC charging station is going to be available with much stronger wattage. And the advantage of charging directly with DC voltage is, of course, that the charging time is significantly reduced. Currently, these are, let's say, the more favoured of the charging connectors, although they are by no means the only ones available worldwide. There are some different types, but you can see here that from the current situation where we have AC to AC charging, this type 2 shortly will be more widely available in a combination with AC and also a DC option. So this means that the customer has much more flexibility when it comes to his charging choices. One worry for the pioneers of such technology is how it will affect them if something goes wrong. And so here I've included some information of what would be the warranty support of this technology. And this is taken currently from an excerpt from one manufacturer. Depending upon the battery type, this warranty period can be from 6 to 8 years or 100,000 kilometers. Now the time and the distance, it's a question of which one occurs first. Yeah. Batteries now are provided with conformity certificates, standard certificates of their power and energy conformity. And the warranty is then related to the battery certificate. Of course, we are at the moment very much in the early days. And so in the next years, we will get more experience with battery technology. And with more experience, I would expect that the warranties can change either down or up. When the technology is very sturdy and very reliable, yeah, we will not need so much of a comfort buffer zone in the future. One big advantage to the full hybrid and battery electric vehicles is that we can have like an onboard, on-vehicle climate control. How would it be in summer when you come out to your vehicle and the vehicle is already cool in a very comfortable temperature range? And this can be achieved with the onboard air conditioning system, powered by the high voltage battery. So the vehicle can be effectively cooled in summer, and in winter can be also heated to comfortable levels. And this pre-entry climate control can be triggered either by the vehicle key. When we are opening the vehicle, the system can be automatically configured to start working. We can also program this directly on the vehicle computer. If we know which time we're going to be using the vehicle in general, we can program start times in order that the vehicle can be pre-cooled. This can also be done via internet connection, via computer, and even more recently by smartphone app. If your vehicle and your smartphone are able to communicate with each other, you can also program remotely the start time of this climate control. And another advantage, if you're having a meeting and your vehicle will be standing for a period of time, when you get out of the vehicle, you'll be able to press a button and the vehicle internal temperature will be maintained at the current level, not increasing and not decreasing during your meeting. So when you come out of the meeting, you can again get back into the vehicle, comfortable and ready to go. Currently, the battery electric vehicles and the full hybrids they have an operating strategy, and they have two operating strategies. One can be reactive. If the vehicle is simply driven according to the gradients and the load of the accelerator, the system is adapting to the most fuel-efficient means of propulsion. Additionally, this technology can be incorporated to include a navigation system. And the navigation system already knows the topography of the terrain. So when you will enter your final destination into the navigation, the vehicle then figures out at which point of the journey it can maximize the use of the electric power to support the gasoline or diesel engine, and also when it can effectively recuperate that power. And we can see that in the blue range here, a much higher state of charge can be maintained, and this will give a much broader operating range and distance compared to the reactive mode. So when used intelligently in conjunction with navigation systems, we can get much greater benefits from range and usability of the hybrid technology. Of course, these vehicles have to be safe. High voltage can be hazardous to the health. And so the high voltage components are typically color-coded, so the technicians or anybody opening the bonnet can recognize, okay, this is a high voltage cable, it's a high voltage component. There are very specific warning signs which are installed at every high voltage connection point. The connector points between the high voltage components are specially designed that they cannot be accessed either deliberately or unintentionally, causing injury to somebody. There's a watchdog circuit called the high voltage interlock circuit, which monitors the connection between all of the cables and high voltage components. And if somebody would inadvertently try to remove a cable while the high voltage system is in operation, this would immediately shut down the high voltage battery and keep the high voltage technology safe, that nobody will suffer any injury. We have also galvanic separation. It means that the earth of the high voltage system is completely separated from the normal vehicle earth. So there's no danger by touching the car, you can get a high voltage shock. So it's a completely self-contained technology. The insulation of the cables and the plug connectors is constantly monitored, and if there will be a breakdown in insulation, either due to humidity or due to damage to the insulation, then the driver would be informed and the vehicle will be made safe. For maintenance and service, anybody repairing the car should also do so in a safe way. And so there is an onboard lock protection where the high voltage system can be de-energized to enable routine repairs and maintenance. And of course, if the car is involved in a heavy accident, then the technology should also recognize via the airbag computer, and the high voltage should be disconnected to save any rescuing people from inadvertent injuries. And finally, of course, such technology requires training. And there are currently 2 levels of training. There's an awareness level of training for people who are going to come into connection with the vehicle for routine works, changing the tire pressures, changing the engine oils, changing the brakes, things like this. And then there's a second level, which is designed for technicians who are then going to do more investigative diagnostic work or repair work. And this is it's in different sections for basic awareness of the high voltage system and then vehicle-specific system training. Thank you very much.
نشكر السيد رزدر على ما قدمه. في حال وجود أي أسئلة من الحضور يستقبل الأستاذ حول ما عرض قبل قليل. بس يجيك المايك دقيقة بس.
البراء اسكندراني من رنف السعودية. Thank you, Andrew, for the very informative presentation. It looks like the battery of choice is lithium, and we all know that the lithium ion and lithium polymer batteries are quite explosive.
It's Arabic. I don't get any English.
Here is talking in English. If you can repeat your question, please.
Yes. So I was just to repeat. I was saying thank you for the informative presentation. Looks like the battery of choice is lithium ion or lithium polymer. We all know that those are very highly explosive materials, and they do run the risk of exploding or catching on fire because of overcharging, undercharging, reverse of polarity, so many reasons. So do you have a standard spec to which you design the cradle or the compartment of the battery? Since we're talking about standardization here, and are there any international standards that we should be aware of to ensure that all of the car manufacturers that bring in such vehicles actually comply with such regulations?
Yes, the lithium ion, as you mentioned, in its purest form is quite unstable and has had some unfavorable press from fire risk and, as you mentioned, from explosion risk. Therefore, the automotive manufacturers are not using lithium ion in its purest form. It's like a polymer of the lithium ion, which is much safer, although it's not completely without risk, and therefore the strict safety measures have been implemented in order to keep the material in a safe temperature range when in operation, and also safe to use in general in public buildings and also at home domestically.
So there's currently no standard, let's say, code or something to comply with across the different manufacturers for us as end users to ensure that we receive this specific type of...
Most of the manufacturers do actually work together in order to implement international standards. And so basically, yes, there is, in answer to your question, there's a kind of a uniformity of the technology that's used across the different manufacturers. Yeah.
سؤال أخير بس للأستاذ اللي لابس عصمة. نعم. راح يكون آخر سؤال لضيق الوقت، نعتذر منكم.
Ibrahim Rahbi from GSO. I would like to thank you for your presentations. I have only one question about the recycling of the battery after accident. If there is any global regulations about the recycling of the battery after the accidents. Thank you.
There are very strict regulations in the transportation of such batteries. And if the battery has been involved in an accident where the casing has been compromised, it's fair to say that it is not safe for travel. And therefore, there should be locally available some kind of recycling procedure. At the moment, when the technology is still fairly low in numbers, this recycling is it's not so popular, but it's very lucrative. You know, for companies which are doing that, they can charge quite high prices.
So the manufacturer take the responsibility to the manufacturer for the recycling of the dealers in the country.
Well, the manufacturers of the battery provide the information which is necessary for a recycling company to do so safely. Then it is the responsibility of the recycling agency to follow the recommendations of the manufacturers and to set up their operation appropriate to that.
Thank you.
يتقدم شرفنا السعادة المهندس عبد الله القحطاني لتكريم الأستاذ ريتسديل فليتقدم مشكورا. أعزائنا الحضور، ننتقل الآن إلى محاضرتنا الثانية لليوم مع الأستاذ دانيال فريكس مدير تطوير في شركة جنرال موتورز، فليتفضل.
Assalamu alaikum. I would like to first thank SASO for hosting such an event, and thank you for inviting me to participate. My name is Daniel Frakes. I represent General Motors. I work at our world headquarters in Detroit, Michigan. I've been with General Motors for 20 years, and I spent a good portion of my career helping develop the policies at the federal and state level within the United States to support plug-in electric vehicles. So today I'm going to talk a little bit about the U.S. market, about some of the barriers that we've seen, some of the items that have supported electric vehicles. I'll talk a little bit about our portfolio at GM. I'll talk about incentives and also about charging as well. So when people are interested in plug-in electric vehicles, these are great customers to have. All of our automotive companies would love to have these customers. They're highly educated, they have good household incomes, they're very technology savvy, and they're interested in the environment. Typically, when someone's looking at an electric vehicle, they are very environmentally focused and very technology focused. This is a word chart from our customers that looked at purchasing and experienced the first generation Chevrolet Volt. And you'll see some of the largest words that pop out that they commonly express is, these cars are fun to drive, they're quiet, they're comfortable. My initial reaction is I thought that the environmentally and fuel efficiency words would pop up more. But when you experience this technology, you'll see that the quiet acceleration of the electric vehicles, the instant torque that only an electric motor can provide, is very satisfying and quite different from the technologies that we're used to driving for the past 100 years or so. Also, these customers have been extremely satisfied with these cars. J.D. Power appeal studies saying these customers are more satisfied with their vehicles than any other market with these electric type of vehicles. We just launched the second generation Chevrolet Volt in 2016, and it was awarded more awards than any other electric vehicle, so we're very proud of this. And you may have heard we're launching the Chevrolet Bolt EV. It just started in the fourth quarter of 2016 in the U.S., and it is getting many, many awards as well. North American Car of the Year, Motor Trend's Car of the Year, and we expect the Bolt, I'm calling it the little brother to the Chevrolet Volt, to get maybe more awards than the Volt itself. Just talking about this technology, as Andrew mentioned earlier, this is what we call an extended range electric vehicle, where you have an electric motor. You can charge this vehicle from energy from the grid. You can drive, say, 50 miles, and then there's a gas motor that acts as a generator to provide more electricity to get you to your destination. You can see from the first generation to the second generation, we've improved this vehicle in every way. We listen to our customers. They ask for more range and more performance out of these vehicles. We increased the range about 40% from 38 miles to 53 miles. The battery size increased from 16 kilowatts to 18 kilowatts. The key thing here is we did this with 100 fewer cells. So this goes to the improvements in energy density within the batteries. Also, key to point out on this slide, you'll see between the vehicles, 80 to 90% of all the trips are being done on electricity from the grid. And what we did was we looked at studies that were out there that typically in the U.S. a customer drives 40 miles or less to and from work every day. So they were able to charge at home, drive their vehicle to their office, drive back to home on a single charge. They don't have to use any fuel. So this has been quite a good technology and a great one to bridge people from a traditional gasoline engine to an electrified vehicle. Now, if we look at the pure battery electric vehicle, no gas generator here, no gasoline motor, just pure battery and electric motors, our first generation had about an 82-mile range, and this was pretty typical for the bulk of the producers at this time. And then we just launched the Chevrolet Bolt EV. I think this is going to be a game-changing technology for us and for the industry to see if customers really will accept driving battery electric vehicles, where you can get 238 miles out of a single charge for a price point of about $38,000 US. Just to round out the types of technologies that we offer, showing our commitment to electrification, not only do we have the largest battery lab in North America focused on the development, durability, testing, and advancements of batteries, we have quite a portfolio, with the Volt being an extended range vehicle, the Chevrolet Bolt EV, pure battery electric, the Cadillac PHEV, which is a traditional plug-in hybrid electric vehicle, and then the Chevrolet Malibu Hybrid, which does not have a plug, but can go roughly get 46, 47 miles per gallon on a large family sedan. So let's talk about the electric vehicle market. This is more of a global view, released roughly a year ago by Bloomberg New Energy Finance, talking about by 2040 that 35% of the vehicle fleet will be electric or have a plug associated with it. They think that it's going to really start to take off in the 2020 timeframe. I'm not buying or selling this survey, just providing the information. But I think, battery costs for sure are going to decline. Energy density is going to improve. The cost of ownership between electric vehicles and combustion vehicles are going to get more on par. But incentives do play a key role. I think even if you get the vehicles exactly the same cost, there's still a hurdle to get someone to try a new technology that they may not be familiar with. Looking at the U.S. specifically, for the past 6 to 7 years, we've seen continuous growth of electric vehicle sales in the market. Since this chart was put together, we did have 2016 sales. We had roughly 25,000 vehicles sold in December of 2016. You'll see it's pretty consistent throughout the year. We get a spike in December, and then typically sales rates get lower in January and February. This is mainly due to a financial incentive from our government that provides a $7,500 tax credit that you can use within a calendar year. So when you get towards the end of the year, we typically see a surge in sales for people that want to take advantage of this incentive. If you look at the U.S. in general, we've sold roughly 500,000 plug-in vehicles in the market. The thing that's surprising to me in this chart is the split between plug-in hybrids and traditional battery electrics is about 50-50. And if you look at this on a global map, you'll see about the same thing. So if we talk about the U.S., looking at the top 20 states in terms of electric vehicle sales, by far California is the best. 50% of all electric vehicle sales are in California. Why is that? I think it's a couple things. One, it's the mindset of the customers in California, but also the government has very good complementary policies to get customers interested in these vehicles. They have awareness programs, informing customers that these vehicles are out there. They have financial incentives on top of the federal government program. And, people's pocketbooks, money is very important. I think time is maybe even more important to many people. These vehicles are eligible to go in the high-speed HOV lane, and that is one of the key reasons that people buy these vehicles in California. It seems to be resonating very well with them. Also, I've highlighted some states in green. These states are part of a zero-emission vehicle mandate that was started by California, and some states have adopted them. You would think that mandating the sale of electric vehicles, that would push everybody to the top. They would all be up there selling those vehicles. I think we should, as manufacturers, we would prefer the market to speak for itself versus having a mandate. And seeing where you have the complementary policies in conjunction with financial incentives and education is truly the way to move this market forward. Great news. We've got lots more models coming into the market, which is great. We're seeing a steep ramp up from 2011 through 2016. Lots of manufacturers bringing lots of models into the market. The thing we are not seeing in the U.S. is the market share isn't following this trajectory. It's remaining just under 1% of the entire vehicle market. And so with that said, I think maybe we're cannibalizing some sales, just moving the same people around within the market, but they're trying lots of different vehicles. The nice thing with this chart is it's not all in one category. It's not all small, compact cars. It's a mixture of sedans, SUVs, trucks, and even small cars. So that is very good news. We were proud. We hit a milestone last year. We sold 100,000 Chevrolet Volts in the U.S., so a technology that we're very proud of. I'm one of these statistics. I ended up buying a Chevrolet Volt in my household in December of last year, so my family loves the car. It's a fantastic technology. When you talk about talking to these customers, you have the layer of what traditional car buyers are looking for: safety, design, features, cost. Then when you add a plug or have the vehicle have the ability to plug in, you have another layer of complexity there that you have to talk to customers about. Charging times, range, are there any incentives? At a dealership level, this can be a little challenging because most people understand gasoline vehicles. When you have a customer coming in to talk about a plug-in vehicle, that dealership employee has to spend more time talking to them, educating them, and deciding if that vehicle is truly right for them. So this is the Chevrolet Bolt EV. 238 miles range, roughly $38,000 US. If you're able to take advantage of the federal tax credit, it gets it down to right around $30,000 US. I think this vehicle is truly going to be a marker for the industry to tell us, how interested customers are in this technology. We're very hopeful they are, because we've invested heavily. All of our companies have invested very heavily in this technology, and we'll see where it goes. The media coverage was outstanding, and I think it was the most talked about car in 2016. So what are our challenges? We talked about energy density and how traditional fuels, gasoline and diesel fuel, have great energy density. You can go 30 miles on gasoline on something that you can hold in your hand. With a lithium battery, you've got, for something that goes 30 miles, it's probably the size of me and weighs maybe 400 pounds. The nice thing about the battery is it doesn't disappear when you use it. You have to use and be smart about what's the electricity and how environmentally the electricity you're using to charge that battery is going to be. Also, you talk about charging times or fill time. With a gasoline vehicle, in 3 minutes or so you can fill up your vehicle. With a battery electric vehicle, it can take hours. But another way to look at it is it could take 10 seconds. I get out of my car, I plug in my vehicle, that takes 5 seconds. I go home, go in the house, have dinner with the family, get a good night's rest, get up the next morning, take another 5 seconds to unplug it, and you're on your way. So depends how you look at it. It could be hours to charge or maybe just a few seconds, depending on your view. When plug-in vehicles launched in the U.S., timing was very good in terms of the relationship to gasoline prices. Gas was roughly $4 a gallon in the U.S. in 2011, making that a critical point for customers to choose what kind of vehicle they were going to buy. So at that time, you'll see there was more cars than SUVs being purchased. Now, gas prices are roughly $2 a gallon in the U.S., and we're seeing a shift more to SUVs and trucks in terms of purchase intent. So there is a direct correlation between gas prices and what vehicles people are looking to purchase. The chart on the left here, you look at the blue bar being gasoline prices and the yellow bar being the plug-in vehicle market share, and they pretty much mirror each other almost identically. Just quickly on the right here, talking about what influences people to purchase electric vehicles. They're seeking out this technology. Most of the ones that are in it right now want to be in it. So they're looking for that particular sort of technology. They're interested in the range. They're interested in whether there's any financial incentives for them. Where if you look at a traditional vehicle market, they're interested in cost, price, quality, safety, things like that, which wouldn't surprise anybody in this room, I don't believe. Leasing is very key to the plug-in vehicle market. You can see it's ranging from 50% up to 90% for a lot of manufacturers out there. And I think it's due to a couple things. One, the technology is new. People are maybe a little skeptical to make a big purchase decision. They would rather lease it and give it a try to see if they'd like it. And also, as I mentioned, these customers are very tech savvy. So they're treating it like their cell phones. They want the cell phone for a couple of years and then trade it out for the next best thing. Unfortunately, the used car market is not being very friendly to the plug-in vehicles. I think they're a little skeptical on the durability of the batteries. So in this example here, a plug-in vehicle after 3 years only retains about 23% of its value compared to a traditional vehicle, which is like 40%. I think this will change because in our view, what we're seeing in terms of the quality and performance of our batteries is outstanding. It is truly exceeding our expectations. We do take great care of our batteries to keep them conditioned. These ones are liquid cooled, so they remain at the optimal temperature. But over 1 billion miles driven, 700,000 of them on pure electricity from the grid, saving 36 million gallons of fuel. And out of 22 million cells produced, we've only had 2 problems per million. So we're calling that pharmaceutical level quality. And I think as these vehicles get more and more into the used market, people will start to be more comfortable with it, and that used car residual value will hopefully increase. Talk a little bit about charging infrastructure. This chart's a little bit odd to read, but it's timelining a particular week, and it talks about where a vehicle is being used throughout a week. The green is where the vehicle is sitting at home mostly, and the red would be sitting at work. So if you're looking at developing charging infrastructure, home and the workplace are the key areas to focus on. If we look at charging behaviors, I would say the bulk of charging is done at home, probably 80 to 90%. This says 60 to 80. That 60% only represents if there's charging infrastructure or charging available for you at your workplace. If it's not, it's going to be done all at home. Through the Department of Energy, from the U.S. government, they did a study that if there's charging available at work, customers are 6 times more likely to consider purchasing an electric vehicle. That's a huge number, and it's also a great idea for awareness, getting your colleagues at work to see these vehicles plugged in and getting a benefit from this. Public charging is more of a perceptual benefit. I think the bulk of it's going to be done at home, but if you're going to have public charging, DC fast charging is probably the way to go. The barriers for people to consider electric vehicles, it's pretty much the same thing. Charging infrastructure and cost are the key ones, but charging seems to show up more often than others. We've led by example at General Motors, where we have lots of charging stations available to our employees and guests. It's free of charge, no pun intended. And if you notice, when I go to work every day, the people that get there early are getting the charging spots, and it's almost a game to see who can get there the earliest, so they make sure they get charging available to them. We released some guidelines internally for our employees to follow to try to share the charging that's available and just doing some etiquette. The other thing that's key in terms of charging is utilities. The organization that's creating the electricity, they should play a significant role in helping educate, offer incentive programs, and maybe giving time of use discounts to their customers. But the 3 areas, we all know this very much: home, work, and public charging. I would say the key that we should focus on is definitely home and workplace charging. Talk quickly about incentives and how incentives do play a critical role here. The chart here on the left from California, you can see through 2012, kind of January, March time frame, the Chevrolet Volt was selling roughly 200 vehicles a month. And then when the Volt became eligible for that HOV lane access and the rebate program, sales went up almost 300%. So it went from roughly 200 to 800 units a month in California, just by clicking on and being eligible for that incentive. On the right-hand side, you can see in Georgia, there was a zero-emission vehicle incentive. The red bars were 2013, the blue bars are 2014, and you can see in July they removed the $5,000 incentive and charged a $200 fee for registering an electric vehicle. And sales went from roughly 800 a month down to 100. So you can see flipping a switch on incentives has a critical impact. So complementary policies, You heard me mention this at the beginning. I think this is key, having a very well-rounded program that is not only does education and outreach to customers, but getting them behind the wheel of these vehicles, offering incentives, either monetary or non-monetary. Andrew mentioned earlier about free parking, for example, is another good offering. But if you have a great package to offer customers, you'll see the sales will come. In the U.S., we have the federal tax credit at $7,500. The green states offer a variety of either rebates or tax credits. Rebates seem to be the most beneficial to customers because they get that incentive right away. Tax credits, they have to wait for that, so they don't get the gratification right off the bat, and they may delay their purchase decision. In my last slide, how do we grow the market? Just keeping a laser-like focus on customer demand, doing the education and outreach, do infrastructure as fast as we can, offering at-home incentives in public, and then, working on the affordability aspect, trying to get those on par with each other. Our CEO, Mary Barra, has said that in the next 10 years, this industry is going to change more than it has in the past 50. I think that's absolutely true. We're seeing vehicle electrification, autonomous, telematics, all these things in vehicles. It's a very exciting time to be in this industry. I'm proud to be a part of it, and thank you again for having me here.
نشكر السيد فريكس على ما قدم. إذا كان هناك أي أسئلة بخصوص ما قدم الأستاذ. طيب الأستاذ اللي هنا مثل ما يجي المايك.
بسم الله الرحمن الرحيم. نشكر الهيئة السعودية للمواصفات على هذه الورشة الطيبة والمتميزة. Thank you, Daniel. And my question actually, as it is a new technologies, how is the maintenance is coming? Is there only the workshops of the companies, or there is a lot of workshops now in USA? Is it the workshop? It is a little complicated. It's not as a normal car now.
Right.
How is the workshop and the maintenance for it? Because this will leaving the people not to buy it because there is not much of workshops.
Yeah. So I think if you look at battery electric vehicles, what we're trying to see and trending to see is the maintenance is going to likely be lower than a gasoline vehicle. The vehicles are definitely more complex, and as Andrew pointed out, there's lots of literature training that's required to handle these vehicles. We have, exceptional programs through our dealership training networks that we offer, and I think just like we're following our traditional service agreements with our dealers and making sure that they're trained appropriately.
أي سؤال ثاني؟ السيد اللي بالنص كانت توصل بعد.
Thank you very much for your presentation. You mentioned in one of your slides that electric vehicle sales are very well correlated with gasoline prices in the U.S. So my question is, have the R&D investments from your General Motors perspective allocated to electric vehicles changed with gasoline prices or not? Versus, ignition engines.
Yeah, no, in terms of how committed General Motors is to this technology, it's not following the same trend. We have made a commitment that this is going to be part of our portfolio for the foreseeable future. We've invested billions of dollars in this, not only in our battery labs, but the vehicle programs that are coming. So we're not letting up in terms of our commitment to this. And we're thinking that now with vehicles like the Chevrolet Bolt that are coming to market, this will be a key telltale on customer demand for these vehicles. Right now, from a business perspective, it's still challenging. This is an expensive technology for companies to produce. And I think over the next generations or two, we're hoping that they'll be profitable vehicles. But right now, that's still a challenge.
طيب أي أسئلة ثانية ولا؟ شيل المايك للجنب.
Thank you for the presentation. In order to fully realize the environmental impact for electric vehicles, you need to couple the electricity resources with the renewable or sustainable resources, basically. Are electric vehicles companies keeping that in mind, working with governments in order to ensure that the source of electricity is environmentally friendly, in order to realize what customers are keeping in mind, especially the environmentally aware customers?
Yeah, for sure. Various parts of the world have benefits of renewable energies. I think if you look at Canada, for example, the bulk of their electricity is generated from hydro. There's other parts of the U.S. that most of their electricity is driven by coal. So there's efforts done in the U.S. to continue to try to focus on making that as clean as possible. There's more work to be done there. It's a little bit out of our swim lane, but we're encouraging the government to keep focus on that. And I know, for example, California's grid is relatively clean compared to the rest of the U.S. And they're making a concerted effort to continue to advance that. So I think you'll see that needs to be a priority of governments to focus on that. And we'll do our part to continue to educate folks on the upstream benefits and requirements around that.
أي أسئلة للسيد فريكس؟
Thank you for the presentation, Mr. Frakes. I have a question. From the consumer's perspective, the electric vehicles and the plug-in hybrids make more sense when the gasoline prices are high. Now, with the oil prices dropping and probably staying at these prices for quite some time, probably 3 to 4 years, how do you see the growth in the plug-in hybrid and the battery electric vehicle market?
Well, the chart that I showed that they are very well correlated. I think as we continue to make advancements in terms of range and battery advancements and cost, that will try to put vehicles on more par and parity with gasoline vehicles, that will help. But I think in the meantime, the incentives and complementary policies are going to be at least the near-term requirement to get that to continue to grow. So I'd say that's going to be the biggest driver for the near term between, having those policies available and then, as the technology improves, costs will continue to come down, we're hoping.
نتمنى من سعادة المهندس عبد الله القحطاني يشرفنا على المسرح تكريم الأستاذ دانيال فريكس. بعد هذه المناقشة سنأخذ راحة حتى الساعة 10:45.
beginning.
أعزائنا الحضور، ورشة العمل ستستأنف بعد دقيقتين. نرجو منكم العودة. ضيوفنا الكرام، نعود معكم بمحاضرتنا الثالثة لهذا اليوم مع الأستاذ يوتشي أيوما، كبير المهندسين والمدير الإقليمي لإصدار الشهادات في الشرق الأوسط لشركة هوندا. فليتفضل. They will come. Or may I call? You can call them. Yeah, go ahead. Just kidding. No, it's okay because it's your time. I don't want to be taken off. Yeah, sure. Go ahead. الو.
Okay. Maybe here?
Put it in the pocket.
Yes. So, shall we start now?
Yeah, start.
Good morning, everyone. Yes. The little bit less audience looks, but in the time being, let me start my presentation. Again, this is Yuichi Aoyama from Honda Motor Japan. First of all, let me say about the thank you for your SASOT invitation for such a big workshop. It's our pleasure to present our thoughts regarding the electric-powered vehicle. And today, not only me, our colleague, two members from R&D, Mr. Noguchi and Mr. Katsuta, also be here. So, after my presentation, any technical question, please ask them. They can answer everything, I hope. Okay, then let me start my presentation here. We Honda has been asked from SASO about these four questions. Then first, definition of electric and hybrid cars and use technique. We Honda have basically four types of electric powered vehicle. The basic one is HEV. Then BEV, battery electric vehicle. The next, PHEV, plug-in hybrid. And a fuel cell vehicle, FCV. This is a very regular one. You know, the engine and the motor, two power source, the hybrid. Then here, the battery is only have motor. It's simple one. Then plug-in, it's kind of unique. I should call hybrid of hybrid. Sometimes run as EV, sometimes run as HEV. The last one is a fuel cell. That is also a unique one. You already know by using the hydrogen fuel. Then let me explain about some technique used to the hybrid vehicle. Three design we have. The first one we call parallel. Parallel. This is the most simple one. Just engine and the motor are connected directly. Then run the vehicle. The detail, please ask to professional. Then next, we call it series. The difference point from parallel is the engine and the motor is not directly connected. Why that design is necessary? Also, that question to the R&D guy. Then third one is we call series and parallel. By putting the power split device, the engine, generator, motor, these are connected. Then work for, sometimes as a generator or sometimes as a powertrain to aim or to achieve the best efficient driving. Yeah, we have these three designs for the hybrid vehicle. Then here, in any design, why hybrid vehicle has a better fuel economy number, we can explain about this energy flow chart. Maybe someone already knows, so I don't need to explain this detail, but you know, the total energy the gasoline has is used for the driving the car. But during the acceleration, much loss there, about 60 or 70 or 80% in the gasoline. by the thermal loss or some run electric accessories, or loss by transmission, rolling resistance of tire, air resistance. Then finally, the part of energy is used to drive the vehicle. That energy is changed to kinetic during the driving. Then finally, in the deceleration, some energy loss also there are. Then stop the vehicle. That in the deceleration also by the mechanical friction, the transmission or rolling resistance, air resistance. Also, our driver's brake operation, the kinetic energy changed to the thermal energy. But hybrid vehicle put the regeneration system, brake by generator. Then the generator produces the electricity that is charged to the battery. Then that electricity is used for next acceleration. So such an energy recycle contribute to reduce, reduce the fuel amount. Yeah, that is the technical explanation. Then, it's a bit complicated. I'll skip this. How much fuel economy, the number is improved? It's one sample in manufacturer has in the US market. Same body, but the powertrain, HEV, and conventional internal combustion engine, ICE. To compare the output performance, it's a bit difficult, but please recognize these are very similar output performance. But you can see the fuel economy number. The HEV has the 60% better fuel economy number than the ICE. Of course, our excuse, that number is produced in a specific testing condition. So it is variable in the atmosphere temperature or your driving condition. But basically, as a specification, in the similar output performance, the better fuel economy number, the hybrid vehicle is achievable. Also, this is too much information. Then next, the EV. It's relatively simple design compared with hybrid vehicle because it just has the motor as a powertrain. So you can imagine the gasoline tank replaced to the battery, the engine replaced to the motor, the control computer is the same. But already the previous the presenter explained in the EV to drive the vehicle and charge the battery and run some accessories, the different type of current like AC, DC, and a different voltage is used. So to connect these equipment, some inverter or converter is necessary. That is a basic design of EV. Final one, FCV. Basically, it's run like EV, but the fuel cell, the producing the electricity is equipped in the fuel cell vehicle. The very, very first generation of this vehicle, of course, the technology is a very, very difficult one, but also the, volume is very big. First generation is only one driver was available. But now, the packaging is almost similar as the other vehicle, ICE or hybrid. So fuel cell stack and the motor is under the bonnet hood, the battery lower the seat, the hydrogen tank here. So we have enough room for the passengers and for the luggages. Okay. let me discuss, talk about the why hydrogen here. To think about to reduce the GHG, global warming gas, or to reduce the fossil fuel using, the basic technology is based on electricity. But the one benefit to use the hydrogen is, I should call energy density. So we can squeeze the amount of energy by changing the hydrogen. So efficient transportation or storage is available, we think. So first, the electricity come from, best is from renewable energy, but even the fossil fuel, by using the electrolysis, change it to the hydrogen, then transport it or storage it, then as our necessity, change it, return to the electricity to run the vehicle like a FCV. Such a cycle is one of the idea for future society. Okay. Then go to next agenda. What is the standard of the international or regional? To be honest, there are lots of regulation standards in the world, but basically, the origin of the standard, as long as I know, it's come from UN, United Nations, or USA. So today, we brought the reference, the regulation from UN and the US. The concept of the regulation for electric powered vehicle is same as the conventional engine. How to keep the safety or how to protect environment. So it's very easy to imagine from electricity, the safety is to prove the electric shock. That is a very major one. And recently, the battery, maybe it's the lithium ion, how to make the safety in the robustness performance. The UNR says please check by this heat shock or mechanical shock, then to check the battery robustness. And also, for the very important safety, if, as I explained, the regeneration brake system on the defect condition, even though vehicle need to stop safely, so such a requirement also in the regulation. The next one is, it's kind of funny. The motor is very silent. That is good, no noise. But on the other hand, that is sneaking from your back. Any non-notification, you may be hit. So such a safety requirement also very important for too quiet vehicle. The last one is the very detailed by using the electricity at the heating, maybe excessive heat happen. So the regulation need to prohibit that. Or even the electric motor powered vehicle sometimes has the oil-burned heater. In that case, of course, it's important to think about the environment condition in the cabin. Yeah. Such a regulation are established for the electric powered vehicle. Then next, the infrastructure requirements for the Saudi Arabia, or the important obstacle. What is that? Here, the item we brought about the infrastructure, we would like to discuss that in the fourth agenda. So here, I would like to talk about the obstacles. Here is the Japanese data. What is, sorry. Still I'm nervous. What is the reason for hesitating to use EV? There are some reasons, the long time charging, or few charge station, or the cannot charge at house, the short range. But the price is the biggest reason, and constantly it keeps the first position from 2020 to 15. So to improve the market share of this vehicle, of course, government put the physical money incentives. And that situation is not only the Japanese case. You can see many countries has such a physical incentive, especially for the very advanced vehicle, PHEV, VEV, FCV. But in the example of Germany, as I explained, the money incentive here, but other incentives also they put, like the prohibitions to register about the current ICE vehicle, or to put to install the more number of the station, electric charging or hydrogen station. That is the one sample of Japanese incentive. Even the money incentive, the Japanese government would like customer to purchase the better performance electric vehicle. Especially they say please purchase the bigger battery capacity, contribute to the longer range. A longer range make less number of the charging station. Government doesn't need use so much tax. Then instead of that, they can pay for the customer. Then here is a very interesting analysis from ICCT, Internal Council on Clean Transport, how affect the physical incentive. The graph shows in the x-axis is the percentage of the vehicle-based price, how much money the government help. Then y-axis is the contribution to the market share. In the macro view, the higher percentage of the incentive works well for the improvement of the market share. But you can see the red circle, the 50%, it's relatively high. But Norway works well, but UK, almost nothing. Why? That is the analysis of the ICCT. The other factors we need to think about. Maybe it's a public charging system, time to use charging, or some special parking. So not only the physical incentive, but also other factors we need to think about. Then final, the electric powered vehicle is suitable for the Saudi Arabia or GCC countries. Of course, all manufacturers pay much effort to meet to the market. But we brought the other point of view. That this slide is the outside temperature in the Riyadh. It's quite wide range in annual, from 5 degrees to 45. Then right side, in this temperature range, the one important factor is the power consumption by the air conditioning. In the low or high temperature, we need to use air conditioning. But the power is consumed by air conditioning, then reduce the driving range. So means in such a case, more number of charging station is necessary. Such analysis is very important. This is the other factor we call wear to foil. to think about to reduce the GHG or using of the fossil fuel, not only the vehicle performance, but also what type of energy is produced from what. So this graph shows the one example. Even the battery EV, VEV itself doesn't have any emission. But if the electricity is produced from the fossil fuel, some CO2 emission we have, still consuming the fossil fuel. So to think about the total, reduction, we need to think about how to make energy for vehicle. So for example, even the conventional engine, if we use the biofuel, we can reduce the GHG or using fossil fuel. But electric powered vehicle has a much potential. If use a renewable energy source, then the BEV or FCV can be the real zero emission vehicle. So what I want to say in this slide is it's important to have to think about the infrastructure and the selection of the type of vehicle. What type of vehicle is matched to the infrastructure? That is the structure. If the society uses a fossil fuel, that can be changed to the gasoline or electricity. So means the electricity also can be changed to hydrogen. So any type of the electric powered vehicle is good match. But for future, if the energy source changes to the renewable one, that make only the electricity, then can be converted to hydrogen. So this type of vehicle is good match. And if biomass is used, then that biofuel is used for the hybrid vehicle. So that is the point. The government or area, national, what type of the infrastructure would like to use, then what type of vehicle they give the more incentive to the customer. That is the key for the contribution to improve the market share, we think. Then here is the last slide as a summary for the 4 agendas. The definition of the vehicle, we have 4 types of vehicles. And what the standards, basically to keep the safety or environment. And what is the biggest obstacle is the physical incentive, money. But other lots of local factors need to be considered. And the last one is match to the GCC country. Yeah, yes, but the key is type of vehicle selection in conjunction with the local infrastructure. That is our thought. Thank you very much. شكرا.
نشكر الأستاذ يوتشي أيومو على ما قدم. إذا في أي سؤال
Thank you very much for your presentation. I have 2 questions. The first question is, in Saudi Arabia, we use the air conditioning system a lot. So when we use it, when we turn it on, is the drop in absolute value in efficiency similar to...
Sorry, could you say a bit louder voice?
So I'm talking about the air conditioning system in Saudi Arabia within the car, within the vehicle itself. Here we're going to use it a lot in Saudi Arabia. So is the efficiency drop due to the use of the air conditioning system in electric vehicles, for example, similar to the same drop in absolute values to conventional vehicles?
Yes.
Okay.
The professional can answer more appropriately.
I am Minoru Noguchi from Honda R&D. Conventional vehicle air conditioner system uses gasoline engine power, but For example, electric vehicle uses electric-powered air conditioner system. So, extreme high temperature condition reduce UV range.
Okay.
Do you understand?
Yeah, reduces it at the same levels with the conventional vehicles or more. Which one is more efficient? Which system?
Yeah. Of course, electric air conditioner is much efficient because we can control compression motor, clutch, connect or disconnect. Okay?
Okay.
Thank you.
Thank you very much.
Please stay.
My question is related to the temperature in Saudi. Is the temperature over here reaching 50 degrees Celsius in the summer? Is it safe to drive electric vehicles in terms of the battery safety when temperatures reach 50 degrees Celsius, or are we going to need additional cooling system within the vehicle?
Yes. On the left hand, that shows outside temperature. We estimate maximum outside temperature under 50 degrees C. And we, OEM, control battery temperature under this temperature. We can control battery temperature by cooling system or car layout.
But are we going to need additional cooling system for environment like the Gulf region, or is it already the same technologies that we have?
Yes, that's right.
The same technologies?
Yes.
اي سؤال ثاني؟ طيب نتمنى من سعادة المهندس عبد الله القحطاني يتقدم لتكريم الأستاذ يوتشي اليوم.
Thank you.
أوكي. أعزائنا الحضور، نستمر معكم بمحاضرة رابعة لهذا اليوم مع الدكتور كاتسوكيو هيروس، خبير بقسم الأبحاث والتطوير والإدارة الهندسية بشركة تويوتا.
Okay, so good morning. So my name is Hirose. I'm very honored to be invited for this kind of discussion. So since I'm lucky to be involved for the first electric vehicle into the society that Prius, I was involved for the development of the Prius development. My boss is now the chairman of the board of the company. So I'm not. Okay, so I will briefly introduce the only available electric vehicle in Saudi Arabia. That is a Prius. So,
birth, beginning of a new existence, evolution, improvement from generation to generation, all that accumulated wisdom. That's what finally brings about innovation. I have questions. The answers are ahead of me. I need to move forward to find them. No matter how far I have to go or how long it takes, I'll keep searching, driving this ever-changing world. Life keeps evolving, from birth to eternity.
okay, so we already sold 1,500 units in Saudi Arabia. So we call hybrids because 20 years ago, the electric vehicle is not preferred name but hybrid is actually the electric vehicle. And also the previous presentation described what is a hybrid and what is the type of the hybrid. Actually, the Pulse is a parallel series hybrid to optimize the use of the energy and propel the vehicle by electricity. So this is the first hybrid. I was involved in 1997, 20 years ago. Yeah, it's a long time ago, and also so for me it's just like yesterday. And then when I brought this car in US, the US people said, oh, this is a country that the water is more expensive than oil. Exactly the situation here. So, and then nobody predicts the US people will buy a hybrid because of in that moment, fuel economy was the 20th preference of the survey of the people expect for the cars within the 20 questions. So the fuel economy was not the issue for US 20 years ago, but if you go to say California or anywhere, you see many the hybrid. So, and when in Japan, we are already 40% of our car sales in Japan is hybridized. So recently, we reached 10 million hybrid sales worldwide. So, and that reduced 74 million tons of carbon dioxide, and still reducing. So hybrid is a very practical way to reduce the fuel consumption, at the same time carbon dioxide. I don't need to talk about this, what is a hybrid, because previous presentation already. So, but very important that our hybrid car is mainly propelled by the electric vehicle, but partially assisted by engines. So to optimize the use, and especially when you deaccelerate, the mechanical energy stored in the battery, and battery is propelling the car in the next push. And so I don't want to repeat this. So, a very important thing is like this. So this is a conventional vehicle. This is the carbon dioxide emission. This is the vehicle weight. So compared with the gasoline, diesel, and hybrid, hybrid is actually reducing 40% of the carbon dioxide, 40 to 50%. That is exactly the cutting the oil usage same amount. And also this is very important to be applicable for not just small cars, for the large cars. Large cars, you save more fuels than the small cars. So hybrid is very important. And also that from the emission point of view, not just carbon dioxide, for the harmful emission like NOx or say hydrocarbon, the gasoline vehicle itself is better than diesel, but hybrid is far below those emissions. So hybrid is a practical way to reduce the local emission and global emissions. And also because why the hybrid Pulse was so well welcomed in the society, it's just not just hybrid is not just for the for fuel saving car. It has the better performance. So in terms of the acceleration, and also the latest one is much better than the previous one. So hybrid is a way to improve the high fuel efficiency, low emission, and power and quietness. And also some of the concern about the battery electric vehicle or fuel cell or the hybrid is durability or reliability. But this shows some of the evidence. So in Japan, many taxis are using the hybrid, and this in Australia, the 1 million kilometer the accumulated taxi exists. So, and I know that Vancouver or many places in the world, the Pulse taxi proves more than 5 million kilometers without any difficulties. In Thailand, so, and also the interesting one is, as somebody showed about the residual value. This is very important for both dealership or business for the automobile. The residual value of the hybrid is quite high because of the more you save the energy or you fuel economy is better, the price of the vehicle remains more variable. So in those markets, the hybrid become very, very preferred. So this is the case. And also the usage of the battery is for cellular phone, you use a this is associated state of the charge. So for hybrid, you have engines. So in case of the battery is close to empty, you can start the engine. So you don't need to empty the battery. So the battery status kept in a very good condition. So this is another question. Do hybrid vehicles require any special maintenance? No, eventually maintenance is almost same as conventional vehicles. So, but at the same time, we have a question about what happens for Saudi Arabia. So, hybrid benefit, of course, reduction of the energy consumption, and also the reduction of the subsidy. Actually, for Saudi, the oil is very precious. This is the source of your income to export. So if you save the fuel, that is the benefit of Saudi Arabia directly, and also that you can reduce the subsidy for oil, and total government merit is huge. But at the same time, what's the burden? Because the price is of course, emission is very low, but price is a little bit higher. So a challenge for the popular hybrid is in US or in Japan, the oil price is higher, the other people say. The savings of oil does not directly benefit for the customer. Directly benefit for the customer. So there's a reason to buy a hybrid. But here in Saudi Arabia, oil is too low. But I hope it won't be continuous because oil is very precious, not just for Saudi Arabia. So oil is very precious asset for the future generation. So we cannot ban for our generation. So I think that we need to work together smartly to how to save those oil into our next generation. So I think that so as it's we need some of the monetary or non-monetary incentives. So in Japan, success are led by those early stage of the incentive to reduce the price difference, and also the so together with the government, we need to educate the people to what is the benefit of the hybrid and so on. So, and also the introduction of those hybrid into the governmental or municipal vehicles, as well as the public bus. So Japanese hybrid market has grown 1,400% for last 10 years or so. So this is very simple. So when you buy a smartphone, it's only or 300 or 500 quid. So if something wrong, you can throw it away. But for car is very expensive. So unless people had a confidence, you cannot buy. So people are waiting until your neighbor is seriously considering. A difficulty is you want the car before your neighbors. So this is a big difficulty for car companies. So also U.S. government has a tax deduction, but not just monetary incentive. Like so, so somebody says the multi-occupancy vehicle lane in Oslo, many people using electric vehicle because you can go to the bus lane. At the bus lane, you can cut 30 minutes, 40 minutes commute every day. So this is one of the biggest incentive for bringing the driving electric vehicle in Oslo. Or in California, HOV lane, in the highway, you can use a multi-occupancy vehicle lane. And also the priority in parking does work. So also as you see, the hybrid market in California grown 600%. So I think when I first brought the Prius into U.S. market, people never predict that the hybrid will be flourishing in U.S. But together with the U.S. government or the people, we have some good, smart source to do it. So maybe we need to work together with monetary or non-monetary incentive to those less oil-consumed vehicles. And not just a way to increase the oil price. That is a very simple solution, but probably not everybody prefers. And also there's a political difficulty to this. I know that. And also the monetary, the very early stage, we don't need those monetary incentives forever. We need to in early stage to stimulate those markets. And also this is a rather short term. For next, the Honda-san introduced, so we are thinking that both pure electric vehicle and fuel cell vehicle. So, what is fuel cell vehicle? Fuel cell vehicle is a pure electric vehicle with hydrogen charge within 3 minutes, and you can drive another 500 kilometers. At the same time, it is a very good way to reduce the future carbon dioxide emission. So because we are targeting also that we recognize the Saudi government or our government or US government, I hope, to cut the carbon dioxide to tackle with the global warming for 80% 2050. We can no longer rely on the conventional engine. So we need hybrid plug-in fuel cell electric vehicles. So hydrogen is a good way to diversify the energy source and to save the precious oil into the next generation, or it's a special purpose for and also the very low emission. And 20 years ago, the Prius was the first electric vehicle to propel the vehicle in a large scale. Then if you replace the engine with a big battery, that is becoming the battery electric vehicle. And then if you put a little bit relatively larger battery to be connectable to the grid, that is a plug-in hybrid. And if you replace the engine with a fuel cell, that becomes fuel cell vehicles. So hybrid is a very very interesting technology to emphasize our efficiency of the old technologies. So new technology needs some kind of the change for the society. So either infrastructure or but very most important thing is the people's preference. So the biggest change of the Prius is because DiCaprio drove the Prius in the red carpet. So Prius become very cool. So it's not just an eco car, it's a cool car. So I hope even Saudi Arabia, those hybrid plug-in electric fuel cell will become very cool to be driven. And also the car is not just for the people bring A to B. So as a Toyota, we need to provide the mobility for small to large and cheap to luxury. So that there are some the function of the vehicle. So for electric vehicle, for relatively smaller car with a shorter driving range, and hybrid is providing a bigger, larger function from passenger to the trucks or bus. And also, as long as we can use the oil, then the plug-in or hybrid is very important. And this can be a future, and I don't want to repeat. So hydrogen can produce only water. Probably here the water is very precious. So. And also the interesting is hydrogen is very, very probably not familiar with everybody, but already largely used in the industry. Like I said, currently the refinery are using a lot of the hydrogen already. And of course, in the future, either of course from the renewable, like solar or the wind power, or some of the fuel like unused energy, like interesting with the sewage sludge can produce hydrogen. This is a very interesting one. So in Saudi Arabia, already you have some potential from the hydrogen oil refinery or ammonia plant, or a soda plant for electrolysis. But in the future, you have more source. I envy you, but because Japan has less than you for both oil and sunshine. So, and the desert is also your asset for the future to produce more electricity. And then you can, if you can produce hydrogen, we need energy for the, so if you produce a very cheap oil, cheap hydrogen, the Japan need to import. So whether I like or not. So we'd like to independent from the energy from Saudi Arabia, but we may rely on you. But this is the future. So I will show some of the interesting video that what is hydrogen.
H2. Hydrogen. A new age of hydrogen energy is dawning. Hydrogen stations are appearing across the US, Europe, and Japan. Why the interest in hydrogen energy now? Reason 1. CO2 emissions, 0. Hydrogen bonds with oxygen to generate electricity. The only byproduct, water. So clean, it's been described as the ultimate in green energy. Reason 2. Unlimited supply. Hydrogen can be extracted from a wide range of substances, including oil, natural gas, biofuels, and sewage sludge. It can even be produced from electrolyzed water, which for our blue planet makes hydrogen an inexhaustible source of energy. Reason 3. It can be stored and transported. Electricity is difficult to store or convey over long distances. But by using electricity to make hydrogen from water, both storage and transport become possible. Think storing hydrogen made in summer for use in winter, or transporting hydrogen made in the south for use in the north. This would mean solar, wind, hydro, geothermal, and other weather and location-dependent forms of natural energy could also be utilized more. Increased use of hydrogen will equal greater sustainability. Described as the ideal energy form to address the challenges confronting humanity, hydrogen is finally ready to become the energy choice for all. Building an extensive hydrogen infrastructure will still take many years. But at Toyota, we thought we'd make a start now, believing it better to move ahead even a little than simply wait. For a future of greater flexibility coexisting with current energy sources. A future in which multiple energy sources support each other. A future that cares about the environment our children will live in 100, 200 years from now. Toyota, driving together into the future. Hope for the future. Mirai.
Okay, so I think that hydrogen car is still a bit long way to go, especially for Saudi Arabia, because of very extreme conditions, very high temperature, very dry condition. But so it takes some time. But all the long distance road, we started with one step. So I think we work together to make some step ahead for the future, and so we need to work together for next generation or next generation. So I'm very much impressed. Your minister said in that the Stone Age was not ended because of lack of the stone. So our intelligence will, I think, change the world. Thank you very much.
نستقبل أي أسئلة للدكتور كتسوكيو هيروس. إذا في أي سؤال. طيب.
Yes, thank you for the presentation. With the very fast and continuously changing and improving technology with hybrids in general, how can the consumers keep up with that technology? I mean, if I buy a car today, and then a year from now or 2 years from now, there's another breakthrough, that would really leave a sour taste in my mouth that I just spent money on such a car. So what do you do as manufacturers to help the consumers cope with this rapid change in technology?
I think the best way is making a very fun to drive car, because people do not care about how the oil, how the fuel is. The people do care about the performance of the car and the styling, and so for other manufacturer, we make a best effort to make the car fun. And also, fourth generation Prius was completely rebuilt in the process of the business, so that it's more fun to drive, and also the fuel efficient. So, of course, it's not so easy, but I hope you like it.
أي سؤال ثاني للدكتور؟ طيب يتقدم سعادة المهندس عبد الله القحطاني لتكريم الدكتور كيتسوكيو. أعزائنا الحضور، ومع آخر محاضرة لورشة العمل اليوم مع الأستاذ مارك كارسون مدير الجودة وخدمة العملاء بشركة رينو، فليتفضل.
Which one am I?
I'm not sure. That's it, I think that's it.
I think that's it. Yeah. And which way was the point? This way?
Give it a try. Give it a shot.
Yeah, we're fine. Good morning, Salam alaikum. Thank you very much for inviting us here today. It's an honour and a pleasure to be able to present to yourselves for the first workshop. Okay, I'm going to talk really more around a presentation to try and encompass all of the agenda, look more probably at maintenance and training, etc. So, electric car. What is an electric car? We look at an electric car as a mobility solution. A mobility solution, obviously, 100% electric, zero emission produced, noise-free. I say noise-free, there is an element of noise because we have to take into consideration pedestrian. So when the car is travelling at slow speed in an urban environment, it can generate noise to make pedestrians aware that there is a car, because the danger is with an electric car, you don't hear it and you could have accidents. So it's all taken into consideration. Driving is a pleasure. We can get regenerative braking. We can also have the charging. The charging is very simple. What we believe today, from what it was 10 years ago, we see the concept has totally changed and the mindset of people has changed in relation to electric car. 2005, our president decided at Renault that Renault would follow the route of electric car. Not so much a hybrid, we would look at electric car. So we've developed and pushed a lot of our resources into electric car. Our alliance partner Nissan, obviously on the hybrid, has now developed hybrid. So we have hybrid in the camp now as well as electric car. If I go back to those days in 2005, 2006, surveys in Europe then showed that 87% of daily trips were less than 70 kilometres an hour. At that point in time, a battery obviously had a range of around about 100 kilometres. So it was considered that the majority of these people would be able to go to work, come home and charge their vehicle. So it was thought that this was the way forward, based on the economy, based on the global change, with climate change, that we would look to reduce CO2 emissions and play a major part in this by introducing electric cars. Today, we look at 150 kilometres and people are looking all the time to increase the range of vehicles. That's one of the things is that we've started. So we've started at a low range at 100, we've moved to 150, and now today we have a 350 kilometre vehicle which has just been introduced last year, which can now go further. So all the time it's been increased. Lithium-ion is the technology. I think you've all heard this morning that we all use lithium-ion, not pure lithium-ion, but a percentage of lithium-ion in the battery. If I currently look today, we've got a 22 kilowatt-hour battery, which we currently use on our ZO, which we have in UAE market, and some of the government departments use the ZO in the UAE market already today. We've now developed the 41 kilowatt, which is our 350 range. No difference in price. So as the technology increases, the price is not increasing. What we're seeing is the price is actually reducing slightly. So we know now, today, it's no different than a mobile phone. A mobile phone started off very large many years ago and has come down to absolutely nothing today. But the price is maintained, except with Apple, obviously, who increase the price every time they introduce their new iPhone. So the other point on the battery that really we need to take into consideration is recycling. Recycling is a major thing with electric cars and within the automotive industry. Recycling, plastics, etc. So it's one thing with recycling. For us as a manufacturer, we take care of the battery. The recycling of the battery is our responsibility. It has a second life, the battery. If the battery, as you can see from the flow chart here, if the battery can be repaired, we have battery repair centres, we repair the battery for further use. If we deem at that point in time, because as everything, as normal lithium-ion batteries, they come to their end of their life in a certain use, we will reuse the lithium-ion in various different other outlets and environments. As you can see there, we've gone through. We then have professional people that recycle for us throughout the whole of the world. So it's generated from France, but we now use recyclers. But the recycling is a responsibility of Renault. Just to give you a brief overview of EV world sales, you can see there, estimated in the world, it was 340,000, which was up 49% on 2015. For us, we are in 40 countries of the world selling EVs today, and our sales have exceeded 100,000 last year based on our vehicle sales of electric vehicles. Incentives worldwide, there are various different incentives, as you can see. Incentives range from carpool lanes, no taxes, exemption breaks, incentives to consumers, free parking, free electricity charging. It varies. Throughout various different parts of the world, everyone is trying to introduce an incentive in line with what the position is within that country. So, if we look at electric vehicles, there's obviously a lot of what we call pros and cons. The pros and cons of electric vehicles, really. The pros, okay, we reduce pollution and the related diseases which go with pollution. Our service costs are reduced by 40%, and our total cost of ownership, based on where we are in the world, can be reduced even more when we look at this. We have increased service intervals. We don't need to service so frequently. We don't have any oil to change anymore. Electric vehicle, electric motor doesn't require that type of maintenance. Lower tax thresholds. You can charge at home, which we've already talked about before earlier. Charging at home is much more convenient. People don't like to queue for gas, and this makes it a lot more easier. We have noise reduction. That's one of the main things as well with electric vehicle. Again, no noise. It's very quiet. If we look at the cons, really, limited autonomy. It's always been one thing, but as we see today, autonomy is increasing. The technology increases, so we are looking further forward on that. We look really, I think your averages for driving is 30,000 kilometres a year, which is 82 kilometres a day. So when you look at that on the average person, again, it's usable to own an electric vehicle, even within Saudi Arabia, within the Gulf states. One point is from a con is the high purchase cost. I don't think we have to forget that, is many of us operate the sale of electric vehicle in different ways. If you take the European model, the battery is financed because the main cost of the vehicle is the battery. 40% of the cost of the vehicle is the battery. The traction battery is the most expensive part of the vehicle. So it's leased, and the vehicle is purchased with a government incentive in many places in Europe, but the battery is leased. The battery comes with an insurance, a leasing package. At the end of the leasing package, the battery is changed, and the battery is owned by the financing company. It's no different than having a mobile phone contract. So in many ways, we tend to find that this model works very well. Here, what we've done so far in UAE, the battery has been purchased with the vehicle, so it becomes the owner. There's no contract. We are, what we would say at this moment in time, in the infancy of electric vehicles. So we don't have the business model to finance for a leasing agreement because we don't have retail customers. It's more institution, government bodies that are looking to purchase electric vehicles today. Lack of incentives. Obviously, incentives is one of the things that drives some of the customers. But I think if we look at the retail side of the business, what we find from retail is you have to be a particular person that wants to own an electric vehicle. There's different electric vehicles, but what we are all trying to do as manufacturers today is to make the electric vehicle affordable and attractive. That's what we need to do. We have to overcome the mindset. Electric vehicles have this mindset of being expensive, when in theory, when you take total cost of ownership and etc., they're not. Lack of infrastructure. One of the big things is with infrastructure. With no infrastructure, it puts a lot of people off. I'll show you an example later in the presentation where there is no infrastructure and it can work. But there has to be a starting point everywhere. And you can start with a very limited infrastructure, that's for sure. Charging time. The charging time, it can depend from an hour to 4 hours based on your planning of trips. It's not seen as to a lot of people as something that's really attractive. The fact is that you have to plan a trip around your charging time. With more infrastructure, that's not the case. Life can become easy. It's just changing your lifestyle. And change is something that everyone does not like, but everyone accepts change once it's forced upon them, that's for sure. Okay, and customer perception. So, just mainly giving an overview of an electric vehicle. Standards and regulations of safety of electric car. Okay, we've got a high voltage system. We've got a 400 volt system with a charging system and electric vehicle, electric motor. That means we've got many, many different safety hazards on the vehicles. But with the UN regulations, UN regulations, this is all addressed within this, which makes an electric vehicle perfectly safe once you conform within the regulations. Just to give you an idea of the main key regulations there, we have R100 electric safety, we have front and lateral impact. Very important, lateral impact, the battery. That's what we talked earlier, someone mentioned this morning about the battery. It's very interesting with the battery and what we have to do to protect the battery. So, just to give you a very quick overview on these points, you can see ECE 100. It protects against electric shock. The vehicle is marked all over the vehicle. If there's high voltage cables on the vehicle, anyone that lifts it, there's triangles put there. It's to make whoever who comes in contact with the vehicle know that's an hazard area. Functional safety, you can't move it on its own propulsion. So all of those things are taken in there. Front and side impact. As you can see there, retention of the traction battery during the impact. It's no part of the battery is obviously located outside of the passenger compartment, shall enter the passenger compartment. That's one of the key things. We've got high voltage battery, could it enter? No. The car has to be reinforced and protected in those areas to prevent that. In the event of breakage, yes, there are procedures that you need to follow or recovery would need to follow, but everything is in place to cover this. Leakage of hazardous materials, electrolyte, okay, up to 30 minutes. There are all first responder standards in place to deal with this type of thing. Range. Range, again, there is a regulation for range. How you measure energy consumption. NEDC cycle, which is New European Driving Cycle, obviously for European manufacturers, everyone, or people that are going to sell in Europe, you will find that you have to conform to NEDC cycles. So you have to carry out these tests. Again, the range determined over various different ways, but there is a range test that covers. So when we say what we can produce on range, it falls within a regulation. Peak power, we measure peak power. We need to know peak power. It's no different than brake horsepower. So what the vehicle produces, etc., there's a regulation for that. As you can see, charging, we need to look at electromagnetic charging, the way the vehicle actually produces on those areas. Braking. Obviously, braking is very key. The braking system is totally different than what you would find on a normal ICE vehicle. You don't have a servo, so the braking system is totally different. So, but it conforms to the CR13, which I think everyone knows is a normal standard, which we currently use, and it goes on from there. So if we look really around the safety, you can see if you take the car, battery casing has to be reinforced. The structure around the battery has to be reinforced. The electrical components, the engine, the charger, etc., have to be protected. So if I look at what we do with Renault Zoe, we work on Euro NCAP 5 stars. It is one of the only B-segment EV vehicles that's been awarded with Euro NCAP 5 stars. So we take safety very, very seriously. It has to be for this. Again, it's peace of mind for the end customer, the end user, because it's a perception thing. I've heard this morning people say about battery exploding, etc. It is taken care of. Believe you me, trust me. Okay, maintenance and training. What we need to look at for electric vehicles are coming into the market is that the distributors are trained. They understand. I heard someone say this morning, earlier on, about these vehicles being serviced outside. It's not advisable because of the level of training we get to the people. They're dealing with high voltage when they're working on the vehicles at times. But you put the vehicle into a mode, allows you to work out of the high voltage range, which protects everything. So that EN standard is a general electricity standard. What we did as a manufacturer was took that, used it, and produced a standard for all our distributors globally to make sure that everything was protected and we worked to a standard. And we put PPE, protective equipment. When people work on with high voltage, they need special gloves that are electrical resistant to a certain voltage. They need face masks, they need etc. It's all taken care of. So what we tend to do is, our objectives is to make sure people understand the dangers of working with electricity. It's a basic need to understand electricity. A lot of people don't understand today electricity, but it's making it what you will deal with electricity outside of an electric vehicle. In the norm, how do you get a shock? The resistance of the body, etc. Coming into contact with damp, humidity, increases resistance, can increase the shock. So we have three levels: ordinary, qualified person, informed person, and ordinary person. An ordinary person can be a customer, can be a salesman. An informed person is someone that needs to know the dangers that it could bring, and the qualified person, the person that's going to work on the vehicle. We put it into three categories: blue, orange, red. Red is for people that work on the battery specialists. There are very few people, it's the highest level. In the main, our distributors, orange and blue, which we find. Battery specialists is something that we set up totally independent to actually distributor. This just gives you an idea from a distributor point of view, what you're going to find within a dealership today of what the level we expect. We talk of lockout technician. Lockout technician is the person that makes the vehicle safe. When it's 400 volts, it's live, he makes the vehicle safe following a procedure. So you can see there, we go from sales executive, validator, throughout the whole operation within the distributor. We also extend this because it's very important. We have electric vehicles on the road. Okay, fine. It's very good. But what happens when there's an accident? Civil defence, police. We provide training as a first responder to these types of organisation. It's part of our responsibility. So you can see, we will do external training. Large fleet users, we have large fleet users. In France, La Poste has hundreds of electric vehicles. So their workshop staff are trained to the same level as our distributor staff on that basis. So we do extend it to that area. We tend to focus on our dealer, but we also make sure that within the country, civil defence, accident emergency, recovery, major recovery companies are trained to handle an electric vehicle in the event of a breakdown or an accident, with an accident. Today, that's one of the biggest challenges we would face in this part of the world is with the recovery, because of the way recovery is managed and carried out today. Each one of these people go through a training program. They are certified and they are required every 3 years to be recertified. So they come back and follow the training program on those areas. So, vehicle maintenance is very simple, it's efficient, reduces time, there's a reduction in spare parts, we don't need to flush the engine, injector cleans, and we get a reduction in environmental waste. We haven't got oil to get rid of, we haven't got oil filters, etc. We don't have to remove those. Again, from a recycling point of view, it's another plus. We look at 34 to 40% reduction in cost. Just gives you an idea, from an internal combustion engine vehicle to an electric vehicle, the components that you're looking at that will need to be replaced during the maintenance of the vehicle, over the lifetime of the vehicle. Infrastructure. Very quickly on infrastructure. You can charge your car 3 different ways, really. You can, what we call the occasional charge, which is with the normal household socket. It takes a very long time to charge a car, but it can be used more as an emergency. It can work in some environments. Public charging station, most common one used within Europe. We see in UAE now we have over 100 charging stations installed. And then we've got the home charging station, which is probably the most popular. Home wall box, depending on what the kilowatt is, it will be around about 3 hours. Green charging cable can be 8 to 10 hours. Public charging post, 1.25 hours. It can be, depends on what you want to charge. Is it 0 to 100%? If it's an average of 80% of the battery, it's 1 hour. We have a fast charge on 43 kilowatt, which is 30 minutes. Now, that depends on the charging capacity of the vehicle, because it depends on the charger within the vehicle, how you charge a car. That determines what charging you need there. You can have a 2 kilowatt charger and put it on the 43 kilowatt. It will not charge in 30 minutes. It will charge in the normal time a 2 kilowatt takes. ZE ready certification and flying doctors. What we have with, from a company point of view, is that when we go to market, we work with partners. We work with partners who install charging stations. We certify the charging station to check the quality of electricity coming from the grid, to make sure that that electricity is of good quality with our partner for our vehicles. So it's a normal thing. We have a team that travel all the way around the world, checking this, checking electricity, checking thing. So we've patented that ZE Ready certification ourselves back in Europe. Just the example that I was going to talk to you about earlier, which I mentioned. If we take the case of Jordan, what we had in 2015, we delivered 150 Renault Zoes to the Royal Court in Jordan. The King of Jordan demanded that he wanted staff that were entitled to accompany vehicles to start to drive electric vehicles. So there was 3 manufacturers involved. We had one of the bigger orders at 150 vehicles. No charging, no infrastructure in Jordan. Nothing existed. They put in place, working with us and some other partners, charging stations, but not 22 kilowatt charging stations, charging points at the offices and in the people's homes. It's enabled these people to carry on their life of going to work and back and using their car outside of work by using these 2 areas and not relying on an infrastructure built in the country. The infrastructure is starting to develop there, but it shows you can do this to start off with without the infrastructure. So the infrastructure shouldn't be looked at as an obstacle from that point. Hot climate testing. There's one point, I think there's been some questions on this. Okay. I came from Renault UK, and I've worked for Renault for 32 years, in 2011. Never did I ever dream that when I came here, EV had started to take off in UK. We were doing a lot of work and we'd done a lot. I didn't come to the Middle East for EV, but within 2 years, someone said to me one day, "You're involved in the EV project in the UK. We want to start looking at EV in the Middle East," which was quite a surprise. So we first started doing a lot of testing in 2012 with a small quadricycle called Twizy, which you'll see at the end of the presentation, which was followed by Renault Zoe, which is our flagship for EV. It's a purely built EV vehicle. It's not a vehicle that was started its life as an ICE and then became an EV. It's pure EV. So we did over 10,000 kilometres in 2013. In the summer, we test in the summer, which is the most key point for us, because we know we will need maximum AC, it's the maximum temperature, and we did 15 different tests on the vehicle before we decided that we would make the vehicle available. Obviously, our big problem today is there is no regulation for EV, so certificate of conformity is more difficult. But with some of the use with our partners in UAE, Dubai Electricity and Water Authority, some of the government bodies want to purchase EV and have purchased EV. So before it had to be ready, we had to carry out the testing. So you can just see some of the snapshot of what we did. We did it on public charging, because charging generates a lot of electricity, so we need to look at that. I can tell you the battery is air conditioned on this vehicle. So we've taken into consideration already use of hot climate. The air conditioning system goes through the battery, so the battery keeps cool. With one of these type of batteries, lithium-ion, if the battery overheats, the power on the vehicle is reduced. That's what you end up. You have a reduction in power on the vehicle. So we know as you can see, our average driving range or autonomy was around 120, 125 kilometres. In our eco mode, because there is an eco mode for the vehicle, which will reduce the power on the vehicle, so you can't drive at 140, it's got a top speed of 140, but you will drive in a mode which will allow you to drive up to about 100 kilometres. You can overgo that, obviously, from a safety point, and with a reduction in AC, we could achieve 150 on that model from there. So we were quite satisfied with that. That's the three that we have tested in UAE. The Twizy is the quadricycle. If any of you have been to Europe, anywhere in Europe, you've probably seen that vehicle and wonders what it is. We have a lot of local Emiratis that own those vehicles in UAE, and they were there before we even started the testing. So we knew we had to do something, because we have vehicles arriving on personal importation and our distributor not being ready to accept these vehicles in for repair. So it's really started from there. You can see Renault Zoe, 300 kilometres today, which is what we're saying on range, and Kangoo van. We have a Kangoo van which is available, which can be used in airport, various different things for that type of thing. Just to finally give you one thing on initiatives that are taking place within the region. Last week, there has been, to promote awareness and education of EV, there's been a road trip, which is Emirates EV Road Trip, financed and sponsored by a number of companies within UAE. We've had 7 Emirates. We've drove through all 7 Emirates, 700 kilometres in 4 days with 10 electric cars. 4 cars were Renaults, 6 cars were other vehicles. And we've got charging station inaugurations. So we now have in Ras Al Khaimah and Fujairah, which are remote parts of UAE, charging stations. Whether they'll get used after the trip is another thing at this moment in time. But our partner has put the charging stations in free of charge to promote EV and promote electric vehicles, because they see further future business. So it's another way of driving the business forward and driving EV, because there are partners there today who are looking at this type of thing. They want to become involved to promote, because they see there's a future opportunity to introduce, once you increase the actual charging stations. So very successful event, was followed throughout by all. A lot of people have become more involved, but again, it's another way that we're trying to focus everyone and obviously raise the awareness about electric vehicles. And that completes my presentation. Thank you.
نشكر الأستاذ مارك كارسون على ما قدم. إذا كان هناك أي أسئلة على ما عرضه لنا.
I'm going to ask in English, so you don't need it. Ahmed Al-Khamis from Al-Jumayh. I would like to ask you regarding the battery. You mentioned it is your responsibility to recycle the battery.
Yeah.
How often you need to, what is the life average of the battery? That's the first portion. The second portion of the question, I didn't see anything, what is about the consumption of the electricity? How much is it going to cost the end user?
How much a car costs the end user?
Yeah, how many watt by kilowatt, the consumption itself?
It depends on the usage. Okay, first question on the battery. Can you repeat the question on the battery, the first one?
The average life
The
for
average
the
life
battery.
of the battery. Average life of the battery is looked at this moment in time based on the European model. Remember, it's different here. We're fully aware of that. It's 8 years. 8 years. Now, we warrant the battery on autonomy. So the battery is warranted for the autonomy because it's like a mobile phone. The more you charge, the more you use, the autonomy goes down. So the life thing. We warrant the battery for 4 years to 80% of the battery. But as I said before, the model is different in Europe because it's leased and the leasing company own the battery and provide an additional insurance on the battery. So, but we stick to that. If the autonomy drops down within 4 years below 80% of what we start with, we handle that under warranty on that basis. So from that side. We don't know what the lifespan here is at this moment in time. We can make estimations and forecasts on that basis, but we need to understand that we need to be serious within the marketplace, and the technology is changing. Now we've got 41 kilowatt per hour battery. So whereas we had 22 on 7 to 8 years, we'll be looking at around 7 to 8 years for Europe. It might be slightly less because of the temperatures here. We know that. But at this moment, I can tell you, on the Europe model, it's 8 years. The actual recycling of the battery, that's our responsibility, okay? We take that because we will take responsibility of recycling as a manufacturer, totally. The kilowatt, difficult question to ask. I've got some figures I can show you based on what we've done in UAE, because the cost of the electricity is dependent on, and when we do it against fuel. I've got some figures there based on the dirham, or 1.83 dirham per litre. Your fuel is much cheaper. So, and I don't know what your electricity is today, but I can tell you there's a massive saving on 1.83 per litre to the dirham based on electricity cost in Dubai. We are saving around about 70% on cost. If I give you an example, I've driven a Zoe for 30,000 kilometres over the last 2 years in Dubai. I've never run out of battery, is one thing. I will tell you that now. I changed my driving style, because that's a positive, I think, is to change your driving style, because you're more conscious of conserving the battery on that basis, so you don't drive so aggressively. So from a safety point of view, it's quite important. I think it's quite a big bit. Oh, my wife tends to say that to me anyway. She says, I drive much better now when I drive an electric car than a petrol car on that basis. But we've looked at, when we did some analysis with DEWA, we were finding that if I took a similar sized vehicle, probably a full tank of gas would have been around about 70 dirhams on 400 kilometres, 450 kilometres. On 450 kilometres of electricity, 35 dirhams. So there's definitely a saving on that. But the cost is dearer of the vehicle to begin with. So it's a total cost package that you have to look at. But yes, so based on your fuel cost, based on your electricity cost, it can be calculated.
Can I ask one small question?
Yeah.
You mentioned that it is your responsibility to recycle this battery. Is there a rebate for the consumer if you return the battery to you?
Is there? No.
You will get it free of charge for...
You buy the car.
Yeah.
Okay. And then at the end, you want to recycle the battery. Okay. You change the battery. If you change the battery, we take the responsibility of the battery. Once the battery's been changed by the distributor, we take the battery back and dispose, or whatever we do with the battery, we reuse it. So within, that is a European model now, is that the manufacturer's responsibility for the recycling of the battery. So it can be changed under warranty. It can be a new purchase battery. We take all of that. So all of the transportation costs, all of the costs to recycle it because it's lithium ion, you don't want to just leave it there. We take as the manufacturer. It's part of the agreement with European Council.
أي أسئلة ثانية من طيب عندي طرف القاعة هناك الله يهينك.
I have a couple of questions also. One important factor actually for any customer when buying a car is the reliability of the car. I'm not talking about the regular maintenance. I'm talking about the frequency of forced outages, problems. How comparable is electric vehicles to conventional cars in terms of frequency and also the downtime to fix any problem in the car? My second question is regarding the quality of electrical supply. You mentioned this in your presentation. You said that the manufacturers have to make sure that the quality of electric supply is within the standards. What's the influence of the electric supply and the performance of the car and also the reliability of the car? If there is, for example, over voltage or harmonics or any quality issues with the electrical supply. Thank you.
Okay, on the first question, the frequency of it's different than no other vehicle. It's a normal car with an electric power unit, really. The electric power unit, at this moment in time, I would say, is more reliable than an internal combustion engine because there's less moving parts that are going to go wrong. But the rest of the components, the wipers, the lights, blah, 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 they're all the same. So there's the same risk as that from that point. But we have less problems with electric vehicles. Although if you take park, the park is much lower. So cases per thousand obviously could increase because the park is low, but the park is low. So we have less problems on that basis. On the second question, regarding the electric supply. Right, the vehicles, we have what we call a chameleon charger on the Zoe. It switches between, it can tell what the input is from the electricity. So it can charge at different levels, that's why it's called chameleon, it switches itself. It is dependent on the quality of electricity and the ground impedance. If the ground impedance exceeds 150 ohms, it trips the charger out. So if there's any overcharging, any spike, the vehicle has built with inside the charging system to just cut straight out. It will stop. So it's got its own internal protection. That's why it monitors. So what we don't want to do is sell cars into an area which has got an unstable electricity supply, I would say, an unstable electricity supply, where consumers are going to experience, I put my car on charge last night, I've got up in the morning, the red light's on there, it hasn't charged, thinking that the problem is with the car. So this is why we send out these people to start doing this on the ZE Ready. We make sure that it's good for the area and the charging stations, etc., are all good. So we do our own local tests to make sure. We have a team in Paris that travel the whole of the world doing this on that basis. So if there's any overcharging, as I said, it's covered. The car has got that protection built into it.
Thank you.
كان في سؤال هنا نص قاعدة تقريبا. تابع معي شوي معلش.
Thank you for the interesting presentation. I have only one question regarding on the test. You mentioned in your presentation that you test your car in the hot climate weathers. But what about the rains? Because in Gulf countries, we have another issue about the rains. After the rainings, there is some waters. It is crossed the roads. Did you test it about this?
Yes, yes. You need to go to Europe, okay? If you go to UK, you'll understand rain, okay? It's not a problem. You can submerge a vehicle. So that vehicle, you could drive in and submerge a vehicle into water. You won't get an electric shock. The only way you would get an electric shock, it would be unsafe, is if you touched the positive and negative terminals of the battery itself. So you'd have to get into the high voltage water. It's perfectly protected for water, so it can deal with that. It's no different than driving a vehicle. If you drive it through a flood, you're less liable to experience the same as you would with an ICE vehicle, where you can suck the water up in the engine hydraulics, but you still could damage the electric motor, depending on... It's not designed to drive through water this high, that's for sure. But under normal conditions, yes, it's perfectly safe.
Thank you.
في اللي انا وعدت وحتى الحين ما وصلت له. لا خليك معي شوي بس.
Sorry. There is a standard which is talking about verification of carbon emission, 17,046. Did you do any verification of quantity of carbon emission in the cars which you are using?
Yes, we do. We do. I don't have the results with me, but we do all of that, obviously. Okay. We have to do that. But if you'd like the information... Is
there any did you work with any place for verification of the reports, or have you got reports or not?
Our regulation people and homologation people in our central office in Paris will have all that information. They will work with the various organisations for that type of information. It's one of the key points in Europe, that will be.
Okay. Thank you very much. Good presentation. Thank you.
Abdurrahman from Haj Hussein Al Ghiza. It seems that the dealer will invest a lot of money to equip his service center and to train his technicians and blah, blah, blah. The question, when I saw the conversion table of the periodic maintenance, I noticed that this EV mobility considered as relatively maintenance-free vehicle. So this gonna affect the dealer revenue, as the vehicle is not requiring, lots of service items. This first. Second, okay, let's answer the first question.
Yes, you're correct.
Yeah.
Correct.
I would like to hear the answer, then I will give you the second question.
No, you're quite correct. It will affect the revenue, but it's not about the revenue, it's about the consumer. At the end of the day, you have to look at it.
So if the investment is too high, then the consumer will pay a lot. Then the labor gonna increase a lot as the SSTs, as the technician needs training. That's the cost is high. Then So how can we compromise? How can we balance these two? The investment is too high, then the labor is too low. Then this is not logical for.
Okay. The investment has to be made by the distributor as a distributor, not as an after-sales entity. This is always the problem. Everyone looks at after-sales. You are selling the vehicle. There is a marginal profit that they take from the vehicle. Obviously, from a consumer point of view, as a manufacturer, we want to sell vehicles. We want to sell vehicles. We want to sell petrol vehicles. We will always sell petrol vehicles at this moment in time. We're always going to, and we want to sell electric vehicles. Yes, you need to understand that as a distributor, as part of one of our partners, that is the way forward. You will make a marginal profit on the sale of the vehicle. It's about increasing the number of sales. The after sales, as a business, there is no loss. Yes, there is an investment, but it's an investment for the future because the balance will change. From the consumer point of view, we look at various different things in after sales. Okay, we will be able to sell extended packages for maintenance, thing. The maintenance cost is all about attracting people to our brand to buy more vehicles. The more vehicles you sell as a distributor, the more profitable you become. So you can't look at it as an after-sales issue. You have to look at it is that if you sell more electric vehicles, you are going to become more profitable, which will offset your investment on that basis. So I understand, and everyone says the same. That's what they used to say in 2005. A lot of people looked at this, oh, I don't want to introduce that. What you will tend to find happen is if our colleagues from GM, our colleagues from Honda, our colleagues from everyone starts to do it, everyone's forced down the same road. So the industry has to change and adapt to that on that point. So we have to change the mindset of the after-sales losing. It's more of a global, it's a dealer investment, not an after-sales investment.
Thank you.
Second, did you have a second question?
It's okay.
Okay.
Your answer was comprehensive,
Okay.
so it's okay. Thank you.
تقدم المهندس عبد الله القحطاني تكريما المتحدث. كذلك نود أن ندعو المتحدثين للانضمام للمسرح للصورة الجماعية إذا أمكن. السيد أندرو ريندزيل، دانيال براكس، يوتشي يوما كاتسيكيورس.
Thank you very much. Thank you. Okay.
I'll keep it to me.
Okay. All right. I'll do some glasses. I can't see.
Tell me about
it. Which way am I going? I'll go on the end. I'll go on the end.
وختاما تتقدم الهيئة السعودية للمواصفات والمقاييس والجودة بخالص الشكر والتقدير لحضوركم وتفاعلكم. آملين أن نلتقيكم بإذن الله بمناسبات قادمة. والسلام عليكم ورحمة الله وبركاته.
Thank you.
If you have any question about the supply plan.